Okay, this video I'm recording for homework 16, which is a review for test 2. And I'm just going to go over a few questions on the review. The first one is number 19, which is about electricity rates. And we have piecewise function, which give us the different rates for different use of electricity. So the function looks like this. This is the piecewise function. So when you use 0 to 300 kilowatt electricity, we need to find the function, and after above 300 kilowatts, we are using a different function, and we have to find the function using this table. I'm trying to get the table. There's the table. Okay, so on the table, obviously, if you use less than 300, we have base charge 850 plus 0.065 cents, 6.5 cents technically, times X. And X represent the use of electricity, which is less than 300 kilowatts. So the first function is going to be 8.5 plus, or 50, doesn't matter, plus 0.065 times X. So this is the first equation we're going to put. If using electricity less than 300 kilowatts. So now what's happened above 300 kilowatts, over 300. So here we're going to have a different charge, which is 8.5 cents per kilowatt. And also we need to set up the equation. So how you do that? So this is what you're doing here, where you're doing the, we're going to calculate how much it's going to cost us to use more than 300 kilowatts. Using that, first, we're going to use the 300 kilowatt, which is going to be 8.5. So when you start using the electricity, it's going to be 8.5. That's the base, plus 0.065 times 300, because that's the limit. I mean, pretty much that's the limit where you cut off the price, different price. So this is what you're going to pay for the first 300, and then plus above 300 is going to be 0.085 X minus 300. X minus 300 represent above 300. So above 300, you're going to be charging 300. There. Okay, so this is how we set up the equation. So below 300, you're going to have this equation, and above you're going to simplify all this expression, and you're going to get the second equation. So now first you have to distribute the parentheses, and I think I have that here somewhere. Let me show you. So we're gonna, there you go. We have when it's between 0 and 300. This is what I have. And then above, so this is the equation, 0.85 plus 0.065x. And now if x is greater than 300, we have what I just told you, the first part here. So this part here, 0.8 plus 0.65 times 300 is going to be the amount you're going to pay for the first 300 you're using. And then above that, you're going to be this one. It's going to be this one. And then we're going to simplify this. So how you simplify this? When I do this, the first part in the calculator, I get 28 plus, and then I distribute 0.085x. And then when I multiply 0.085 times negative 300, that's negative 25.5. And then when I combine those two numbers, that gives me 2.5. And that's the equation for the second option when you have X is greater than 300 kilowatts. Okay, so that's what you're going to put here. This is the answer. And I have it here, plug it in into the homework. Then after that, we need to pick which one of the correct graph is given here, the function, this piecewise function. So what you need to do is you have to, I'm using X equals 0. So you need to see where the Y-intercept is going to be pretty much, because that's what is different on these graphs. You see this one starts at 0, 0, the first one. The first graph here starts at 0, 0. The next graph here also starts from 0, 0. So obviously it's not those two first. So it's going to be B or C. See, B starts close to 20 and D starts low. It's kind of close below 10, pretty much. When you zoom it, you'll see. So what you're doing, you replace X with 0. X is 0. You're going to plug it into the first equation. And it's going to be 8.5 plus 0.065 times 0. This gives me 0. So the Y coordinate, the Y-intercept is going to be 8.5. And that's the right graph, the one we have over here. Mine is graph G. So this is the right graph because we have Y-intercept at 8.5. Okay, so that's how you do number 19. So to pick the right graph, we use X equals 0, which is 8.5. And this is where you cross the Y-axis. Okay, that was number 19. That's the one we couldn't finish in class. And then I have a few more for you. Number 22. Number 22, we have function F, function G. We have to graph them in the same coordinate system. Pretty much you need to pick the right graph. You need to solve when they equal to each other, when F is above G and when F is below G. That's what you need to do. And after you graph it, you'll see it's really easy from there. So how you pick the right graph? So what I'm doing first, I'm going to solve the function F equal function G. And I'm going to also, that's for B actually, sorry. First, you're going to graph it. So how you graph it, you're going to analyze the function F, analyze the function G. So looking at my function F, this is F. When I do the parentheses, this is what I get. See, I'm distributing. Negative 0.8 times x times x times negative 0.8x times negative 9. That gives me this function. So I do the parentheses. This is how the graph, this is how the function looks like. So this graph is open up. I'm sorry, it's up and down because we have the number in front of the square is negative. That's why it's up and down. And we find the x-intercept when you solve it equals 0. This is 0 and 9. Those are the 0 and 9. You're crossing the x-axis at 0 and 9. And also the parabola is up and down. So looking at my 4 graphs, it's not C because C is open up. The parabola is open up. And it's not, oops, sorry. It's not, actually C is the only one you're going to exclude from these graphs. Everything else is, all the other graphs open up. Also, we're going to look at the function G. So far we have A, B, or G, because all of those are up and down. And we need to see which one cross at 0 and 9. Now, looking at the last graph, G, we're crossing at 6. See, this is where you cross the x-axis. You're crossing at 0 and you're crossing at 6. So this is not the right graph also, because it's up and down, but it's crossing the x-axis at 0 and 6, not 9. See, we have x-intercept at 9 and x-intercept at 0. So using the function f, we eliminate choice C and D. Now we're going to look at A and B, which one is the right one. We're going to look at the graph for function G. And G has, it's a linear function, 1.6x plus 5.6. Looking at my function, the number in front of x is the slope, which is positive. That means the graph is increasing. Both of those graphs are increasing, obviously, so nothing so far. Then you're going to find the x-intercepts. We're solving the function equals 0, and that gives me negative 3.75. And looking at those, it's not very clear which one of those it is. And then you find in the y-intercept. and the y-intercept is at 5.6. Y-intercept is when you replace x with 0, you get 5.6. So looking at the graph, this one, this graph is at 5.6. This is the point here where you cross the y-axis, and this is a little lower, so low here. So it's not A. So that's why we pick the graph B is the right one. Okay, that's how you pick the right graph. Just analyzing the linear and the quadratic function we have given. Then the next one, the next part of this question, we need to find f equals g to see which points is that. So here what we're doing, we just take the function f equals the function g. It's a quadratic equation. You can use symbol up. I use symbol up faster to solve it. You can use the quadratic formula. You can factor. You can do the way you know how to solve quadratic equation. This is quadratic because you have x squared. And these are the numbers I get, 1.21 and 5.6. So those are the points where f and g intercept. So how you find those 2 points? When you solve f equal g, give me the intercepts of the 2 graphs, the graph f and graph g. And you're using just solving quadratic equation. And then the next C, it's asking me which value of x f is greater than g. F is greater than g means the graph of f is above the g. And see here you can notice also the x-intercepts. I mean the intercepts of the f and g. It's exactly what we get. It's exactly what we get here. See, those 2 numbers are the same, but you can see those before you do B. So you have to just use quadratic formula and solve it, or use the symbol up. Okay, so after you, now how you pick which one of those A, B, C, D, E is the right answer. Now, looking at the graph, we can decide. It says F is greater than G. So this was the right graph, right? This is the graph we're looking at. So now they're saying F is greater than G. F is the blue graph. So the blue graph is above the pink graph from the yellow point from, I'm gonna use, so from this point to this point, exactly the intercept, and see between those 2 points, the graph F is above G. So that's why you have between the two intercepts of the graphs. So that's why you pick C. And then D, where F is less, so it's going to be outside, in the other side. So it's going to be from 0 to 2.1 and from 7.9 to 8, because that's where the graph is given, only from 0 to 8. So that's how you do number 22. And then I have another one here, 23. 23 is, we have the marketing research department sell memory chips for microcomputers to be, we have the price demand function and we have the revenue function. So this is given. We have P of X, which is the price function, and we have R of X, which is the revenue. Revenue is price times quantity. And if you see here, revenue is X times P of X. That's exactly what revenue is. Revenue is price times quantity, okay? And then they also give me X times 80 minus 3X, so just multiplying them. So now, how are you gonna find which graph is the right graph for the function R, for the revenue function? So what I'm doing here, I'm taking the revenue function, which is given. So I'm multiplying the parentheses, see X times 80X, X times negative 3X, and that gives me 80X, this one down here. So we have the function, the revenue function is 80X minus 3X squared, which is quadratic, negative in front of the square, it's up and down. So that means it's not C, because C is up and up. So it's not this one. And then you have to see which one it is, A or B. And we decide that using the x-intercepts. How you do the x-intercept? You solve x equals 0 and 80 minus 3x equals 0, which give us 80/3, which is 26.7. And then looking at my graphs, because it's a positive, so this is very important here. It's a positive intercept. That's why it's the graph B, because looking at A is the graph in A is crossing the zero, and also at negative side of the x-axis. We need to be at the positive side of the x-axis, so that's why it's the graph B. Okay, and then the next one, the next question they're asking is find the output that will produce maximum revenue. So now we have the revenue, it's the graph of B. This is my graph. So what you need to do is find the maximum, which is at the vertex. So we're going to find the vertex using of the function revenue is negative 3x squared plus 80x. You're using the formula to find the vertex, negative b/2a, which give us negative 80/2 times negative 3, which is 40/3. Make sure you reduce that fraction, because if you just put 80/6, the homework is going to say is wrong. You need to reduce it. So it's 40/3. You have to reduce. And then the next one is what is the maximum revenue? We know we're going to have maximum for 40/3 million chips. So what you're doing, you just plug it in 40/3 into the axis. And in the revenue function, that gives us negative 3 parentheses 40/3 square plus 80 times 40/3, and then calculator, and you get 533.33. Now we have to round 2 decimal places. That's what it says. So make sure you round 2 decimal places. See, in the one before, it says integer or fraction, simplify your answer. So for B, make sure for the first one, make sure you leave it like 40/3, reduce it. And the second one for the million, how much is the maximum revenue? You have to round 2 decimal places. So be careful how you round the numbers. And then the next one, they're asking C, they're asking me to find the price that produce maximum revenue. So this is what you're doing now. We take the price function given and plug it in 40/3, because we know when you produce 40/3 chips, a million chips, you're going to have maximum. And then the maximum price, we're plugging into the price function, which is 80 minus 3x, and just plug it in and we get $40 is the price you're going to sell the chips, the microchips. Okay, so that's how you do 23. And then I have one more, which is 26. And I think that's the last one I have. Yes, 26. So number 26, it's about, what is it? A company is planning to manufacture snowboards. The fixed cost is $400 per day, and the total cost is $5,600 per day at the daily output of 20 boards. This question was also in homework 15. So if you understand how to do it, you don't need to watch the end of the video, but I just doing it one more time just to refresh. And here what you have given is the cost is fixed cost plus variable cost times X. The fixed cost is 400, so it's going to be 400 plus the variable cost times X. We need to find what is the variable. If you produce 20 boards, the price is going to be, the cost is going to be 5,600. So we have X and Y coordinates given. We're going to use this X and Y, plug it into the function, and you're going to find what is the variable cost. So Y is 5,600 equals 400 plus variable cost times 20. We're going to subtract 400 in both sides. So that gives us 5,200. And then you're going to divide by 20, and that gives us 260 is the variable cost. After you find the variable cost, you're just going to get the final equation, which is fixed plus variable times X. And this is the final answer. And then the next one, they're asking what is the average cost. And average cost, they give you the formula, which cost over X. So pretty much you copy that answer from A and just put it over X. Nothing else. And then you have to pick the right graph. How you pick the right graph? We're just going to analyze the function again. We have fraction function. So the average cost function is fraction. We're going to find the vertical asymptote when you solve the bottom equals 0. So for the vertical asymptote, Here we get in x is the denominator equals 0. That's my vertical asymptote, which x equals 0 is actually the y-axis. And all of those graphs have vertical asymptote at the y-axis. Now, also we need to analyze, that doesn't give us choice, right? We can't pick which one is the right graph. So then what you need to do is all of those graphs have y-axis is the vertical asymptote. So what you're doing next, we're gonna take the horizontal asymptote, which is, there are 3 cases for that. If the highest exponent up and highest exponent down in the fraction are the same, the horizontal asymptote is y equals the number in front of the x in the top and the number in front of the x in the bottom, which is 1. So it's going to be 260 over 1. And that's your horizontal asymptote of 260. And then we're going to see where the horizontal asymptote is. The first graph, the horizontal asymptote is at 260. That's exactly where it is. This is horizontal. Here the horizontal is at 400, so it's not B. Here it's at 200. This is horizontal asymptote. And here it's at 100, so it's not the last one. So the answer here is A. And then one more question they're asking, what is the average cost per board tend to be as production increase? So if production increase, that means if X approach infinity. So if you're going bigger and bigger, so looking at the graph now, the graph is going like this, and it's going bigger and bigger. You're going close to the asymptote, to the horizontal asymptote, but you never cross it. So that means 260 is going to be the average cost per board when the production increase. So when production increase, the average cost should be about $260. So that's what you're going to put there for D. And that's it. So that's for today. The test is going to be on Monday. I'm going to send an announcement with the password for the test. Take the test, and I'll see you all on Wednesday. Have a good day.